I'm sorry. So my connection was not stable. So let me reset the okay. Okay, let me. Okay, sorry. My connection was not stable, so I have to repeat. Okay. Where will we? Oh no. Okay, so we resume. So one way that we can tools that we can have is using a fast Fourier transform. Okay, so let's say we have the ideal signal. Okay, the ideal signal here. Okay, so we can estimate. Okay, here the first we have to estimate the period. Okay, the period is about 0.7 minus.
Sorry, sir, we can't see the screen.
Oh, you cannot see the screen. Okay, okay.
Ah.
Okay. Keep. Oh, you cannot see the screen. Let me see again. What is happening? Let me share. All right. Share. Can you see now? Can you see my screen?
No.
No.
No, huh?
No.
Hang on. Let me check. You share. How about now?
Yes.
Yeah.
Now you can see?
Yes.
Okay. So it is very weird. Okay. Okay, so one way we can use a fast Fourier transform. Okay, so first we need to estimate the period of the signal in time domain. So we can estimate the time, the period is about 1 second. So the fundamental frequency for the original or the ideal signal is about 1 hertz, if I'm not mistaken. Okay, and the amplitude is the amplitude AO, okay, is 1. Okay, let's say this volt 1 volt. So if used for fast Fourier transform, okay, it will convert the signal into frequency domain, and then it will show the component, okay, of the signal in discrete form. So the ideal signal, the only signal, the main signal is around 1 hertz, okay, 1 hertz, and we can say the amplitude is 1. Okay, A0 is okay. Okay, never mind. I think our class is going only left 10 minutes, but I think it's okay. I will continue. So we have, okay, but if we, let's say the ideal, and then we inject, okay, purposely or this noise exists on the ideal signal. So if we perform the fast Fourier transform, so we can expect that, okay, the frequency in this, okay, A0, of course the original will be there, the original component, okay, of the signal, okay, but it will contain, okay, other component, okay, which is the noise, okay. If the case is very severe signal, okay, the noise is very severe, so the amplitude of the noise will be exceeding the original signal. So that is a good example you can play around. Okay, you use this as your lab view, okay, lab view example, and then you can proceed by how you can eliminate this by using a filter. Okay, filter. Okay, just give you some idea. You can use filter block in lab view, which is a good example that you can try. Okay, for your assignment. All right. And then while we study noise, there are two limiting factors in the performance of communication system. In communication, there are two limiting factors. Okay, and of it is noise. Okay, another one is the bandwidth bandwidth of the communication channel. Okay, channel. So basically, these are two in basic communication. If some of you taking the basic communication class, so noise, okay, and bandwidth are the limiting factors. Okay, so these two will determine the quality rate, quality of the transmission rate. Okay, quality of the transmission rate in the communication system. The problem is that, okay, they are exchangeable, means that to, let's say for example, noise, if you want to reduce noise, you can increase the power of the original signal. Okay, the power, you increase the power of the original signal, okay, then you can reduce the noise. But when you increase the power, then it will affect the bandwidth. Okay, the bandwidth will go down. Okay, okay, but if you want, you can increase the bandwidth. The bandwidth is the frequency band. Okay, like now we have 5G. That means that 5G is you can give analogy like a 5-lane highway. Okay, you can put a 5-lane highway. But for example, but the problem, if you have a 5-lane highway, there will be more cars. Okay, more cars means that there will be more noise. So they are exchangeable. So one you increase, another one will decrease. Okay, that so in communication system there should be a thread balance between the noise and bandwidth. Okay, so basically electric noise is any undesired voltage or currents. Okay, we will look into how, okay, noise we can quantify, or we will look into what are the type of noise that is can be quantified by with the voltage value, and also some of the noise which is can be the variation of current. Okay, so and then this noise, okay, exhibit in the receiving part, or the receiving output, or the output, we can say the output. Okay, example has a static. Okay, in AM radio now, our radio transmission is still using analog. Our digital TV is already shift into digital transmission. Okay, one of the main costs going for the digital, okay, digital transmission is because it produce it consume very less power as compared to the analog system. Okay. So but radio, we still using analog modulation radio. If the transmission is not that good, we can still hear the static noise coming into the radio. Okay. Okay. So before we end our class, maybe we will look into the quick example of noise. Okay, it can be divided into two types: external noise or internal noise. Or some may refer, you may find other example in notes. It called extrinsic noise. Okay, and or intrinsic noise. Okay. So these are two type of general type of noise. Okay, intrinsic noise or extrinsic noise. So extrinsic noise is basically noise introduced into the transmission system, or noise coming outside from the system, or from the circuit, or from the electronic circuit, or from the measurement, or from the instrumentation. Okay. And intrinsic noise is noise generated within the system itself, or electronic circuit itself. Okay. Okay, you can see for this example, okay, we have a transmitter. Okay, okay, receive an input. Okay, of course, internal noise. Okay, there are some internal noise in the transmitter, of course, and when it's sent into the medium for transmission. Okay, so the medium, okay, can be open space, or can be wired, it can be wireless. Okay, they introduce extrinsic noise. Okay, we will look into the type of this noise. Okay, the receiver will decode the data or the information, and then we recover into the readable form, or we can some form that we can make use. Okay, and then we can understand. So the recovered information will contain the noise from the extrinsic and intrinsic sources. Okay, so those are the basic type of noise. Okay, we will look into many type in the next class. Okay, so before I end, I think from beginning tomorrow, I will migrate our lesson in using WebEx. Because I don't know. Last time, because I have to apply for from UTM to use the WebEx. Now I have got the account for WebEx. So inshallah, from tomorrow we will resume our class using WebEx. I will configure the WebEx session for tomorrow, and until the end of the class. Okay. With that, I think I stop lah. I stop. Maybe if you have any question, you can ask now, or until our session automatically finish, or maybe you can send it through the WhatsApp. And with that, I would like to wish that you all have a safe day, and also please keep safe, and always maintain a very